Hey folks, Mr. Dell here. We are looking at given a story problem, can I interpret that with a graph? So I'm taking this problem from CPM course 3, and this is section 4.1.5, number 4-53. So it says sketch a graph to match each story below using axes labeled as shown at right. So I'm going to do part A and B. So it says Lewis rides his skateboard at the same speed all the way home. It takes him 10 minutes to get there. So if I think about what's happening, Lewis is on a skateboard and he's on a constant speed, same speed. And then it takes him 10 minutes to get there. So I got some information to deal with. So speed, you notice, is my y-axis. And as I move up, speed increases, right? So this is my y-axis. And time is on my x-axis. And as I move up, time increases. So as he's riding his skateboard, time is increasing, right? So as time increases, does his speed increase or decrease? Well, it says it's the same speed. It doesn't go up or down, but time continues. So what we would have here is a graph. I could just choose any speed of what he's at. There's no markings here. So say it's here, it's this speed. He's continuing at the same speed, right? And time does continue, right? Here's, I don't know, 1 minute, 2 minutes, 3 minutes, whatever the case is. But what I do know, because it gives me this information, I'm going to add a little bit here. I know at 10 minutes, and we're going to put minutes in terms of my time, right? Because it's at 10 minutes. It takes him 10 minutes and he gets there. So at 10 minutes, he arrives. So then what happens to his speed at 10 minutes? He's constant all the way he gets home. As soon as he gets home, it slows way down and comes to a stop. And it may be actually a lot quicker than that. I should maybe drop down quicker because it doesn't take him a full minute to stop. He just comes to a stop. So it'll come down pretty quick. So there's one interpretation of that stop there. But the major thing that you got to know is it's going to be a horizontal line because it's a constant speed. Okay. And then let's look at B. Karina jogs along at the same speed until she reaches a hill. Then she slows down until she finally stops at a rest. Stops to rest. So she's jogging, again, speed and time. So she's jogging along at the same speed until she reaches a hill. So our time is starting here, right? And our speed is here. So this is speed increases, time increases. This is my X, this is my Y. So if she is jogging at the same speed, again, it's going to be a constant speed as time goes on. But I'm going to actually do something a little different. I probably should have done it up here. I probably should have started here. I might actually change my work here. I'm sorry. Because if you think about it, at 0, he didn't automatically immediately start. He had to ramp up his speed until he got there. So I'm going to actually adjust this. I'm going to say, I wish I don't have any eraser. I did doing this a pen. He increases his speed till he gets to a constant speed. So he ramps up his speed. His speed increases. It takes him maybe about a minute to get to his constant speed, or a half a minute, or whatever the case is. And now he's at his constant speed until he gets home. So that would have been more like this. So I'm going to do that same thing, that same idea here. At 0, because this would be at 0, right? At 0, she starts to jog. So she ramps up to where her constant speed is. She gets going, and then now she's at a constant speed. And it stays the same until she reaches a hill. So now, so she's constant for a while. Now she's getting to this hill, however long it takes her to get there. At the hill, then she does what? Slows down until she finally stops. So she's climbing a hill. Her speed is actually slowing down, right? It's getting less until she finally comes to a stop. So it wasn't a fast stop. It's a gradual stop. Her speed slows down and then she finally comes to a stop. So hers might look like that. Okay. All right. There we go.